So if the answer is yes, then the thing you're talking about is an ion. Okay, so how do you name ions? Well, you can have positive ions, which are called cations, and you can have negative ions, which are called anions. So let's begin with the cations. So cations, in this class, will always be metals or ammonium ion. Okay, so I'll come back to those in just a second. Let's leave ammonium out, but let's talk about metals. So on the periodic table, you have column 1A, 2A, you've got a bunch of middle ones, and then you have this over here and a couple rows down here. Okay, right here on our periodic table, we see a sort of a green stair step. Oh, which ones are the metals? Well, in our class, we've said everything that's this way from that green stair step is considered a metal, including these two rows down here, which are called the lanthanides. Everything over here on this side are considered nonmetals. Now, that includes hydrogen and helium. Now, in reality, there's a couple of atoms that touch the stair step that are considered metalloids, that have some properties of metals and some properties of nonmetals. So we'll ignore those for now and keep it as simple as we can. So if something isn't a metal, metals always make positive ions. These columns out here are called the main groups. Okay. Now, this up here, boron, is not a metal, but things below it are, below the green stair step. The main groups obey sort of the octet rule that we described in class. And this column here, that entire column, makes a positive 1 ion. Everything in this column makes a positive 2 ion. This column makes a positive 3 ion. Okay? Because they only make 1 ion, you do not need to say what the charge of the ion is. So, for example, sodium is in column 1. So sodium makes a positive 1 ion, and the name is sodium ion. All things with a charge have the word ion in their name. I do not need to say what the charge is because it's in column 1, therefore it's positive 1. Magnesium is in column 2. Its name and charge would be magnesium ion and have a +2. Okay, aluminum is in column 3, right there, and it would be aluminum ion, has a +3 charge. This section here, including the lanthanides, these are called transition metals. You'll learn later that the transition metals, the outside electrons are in d orbitals. That's not something we need to worry about right now, but that's what makes them a transition metal. Transition metals can make more than 1 ion. So once again, they only make positive ions, but if I gave you, for example, iron ion, iron can make 2 different ions, a +2 and a +3. Now, there is an old-fashioned naming system that we're not going to use, where the ending, when there's 2 different ions, ends in us or ic. For example, the Fe3+ is ferric ion, and the Fe2+ is ferrous ion. We're not going to do that. We're going to do something a little more simple. It's called stock nomenclature. And what they do is say, well, whatever the charge is, let's make that a Roman numeral. So that's iron 2 ion. And this one here would be iron 3 ion. Okay? That's what you need for the transition metals. Okay, so now we've named virtually every cation we're going to have in this class. There are a couple of exceptions. The first exception is zinc. Zinc should need a Roman numeral because it's a transition metal, but it only makes a +2 ion. So we'll put this on our flow chart. Normally in college you would memorize that. Zinc ion doesn't get a Roman numeral, nor does silver ion, which is a +1, or cadmium ion, +2. They should get Roman numerals, but they're exceptions. In the places where they're not supposed to get Roman numerals, we have 2 exceptions in our class also. Lead ions can make lead 2 or lead 4, so they do need a Roman numeral, even though they shouldn't because they're not transition metals. Also, tin can make a +2 and a +4. Okay, so those need Roman numerals. So Sn plus 2, so tin would be tin 2 with Roman numerals in the parentheses, ion, and tin 4 would be Roman numeral 4 ion. And so those need Roman numerals even though they're not supposed to. There's one more cation or positive ion, and it's actually called a polyatomic ion. It's NH4 plus. I'll come back to that in a few minutes. That does not have a logical way to name it. These have logical ways, at least some rules. This polyatomic ion, an ion made of many atoms, the only way to know the name of it is to memorize it, and that's ammonium ion. Okay, so there's how you name positive ions or cations. What about the negative ions? The anions. Well, the anions come from this area over here, okay, where this right here is carbon, and carbon can be a 4 minus, this column. And when you get to this column out here, the final column, those are the noble gases or the inert gases. They don't make ions. So the column with fluorine is column number 7. They call it 7A. That means there are 7 valence electrons, which means one more valence electron would be 8. So this entire column that has fluorine in it makes a negative 1. So fluorine, chlorine, bromine, and iodide. So how do you name a negative ion? Well, if it's a single atom like that, then to name a negative ion, let's give ourselves a little bit of room here. For example, F minus. Well, the negative ions, you just change the ending, Fluoride, to an ide. Okay, that's how you can tell that the ions are negative. For example, sulfur is in column 6A. So 6A means it has 6 valence electrons. 2 more would give it a full octet. So sulfur is going to make a negative 2 ion. And once again, since it's only sulfur, it's called sulfide ion. Okay? Nitride would be -3. Carbide would be -4. And so you can tell the charge of the negative ions by what column they're in. Now, there's also negative polyatomic ions. For example, NO3 minus. Okay? That's called, well, that doesn't have a logical way to name it. It's called nitrate ion. NO2 minus is called nitrite ion. And we've given you a list of all these ions to memorize for this class. There's quite a few of them. They're kind of a drag to memorize because you have to memorize the formula and the charge and the name. But that is a single object that has a -1 charge. Okay, that's how you name ions. Now if we go back to our flowchart, you can see that we now have answered this question and we know how to name ions. Okay. Now I suppose when we're naming positive ions, I guess there's another question we should ask ourselves to remind us of the rules we just did. Is the positive ion or the cation, metal ion, a transition metal? Because if the answer was yes, we need Roman numerals. And if the answer was no, you don't need Roman numerals. And so the examples of that were iron 3 ion needs a Roman numeral, and calcium ion does not. Okay. Anions. Those can be figured out from the periodic table, or they must have been memorized as one of the polyatomics. Okay? Don't forget that if it does, that both of these columns have exceptions. In the ones that should need a Roman numeral, you've got zinc, cadmium, and silver. And the ones that shouldn't need a Roman numeral, you have the lead ions and the tin ions. Okay, so those are the exceptions. So that's how you name ions. Our first question was, does it have a charge? If it has a charge, that means there will be something here with a number, a positive or negative number up top. Okay? That's how you recognize an ion. What if it does not have a charge up on top? Okay? I guess that means our answer here would have been no.